The coders, in this video we're going to talk about a feature that can save a huge amount of time, and it is generally cool. So let's switch to the code. Alright, so starting from Python 3.7 we can create something that's called data class. But first let's remind ourselves how a regular Python class looks like. So I've just copied this one from the lesson on magic methods. If you haven't seen it yet, I would recommend you to go and see it. The link is in the description. But meanwhile, I'm going to import the data class from the data classes module, and I will write a decorator data class. All right, so now that the Python interpreter knows that this is a data class, we can start changing it. So first we got rid of this init method. Then we can get rid of self. And since now we have those redundant values, as in make equals make, model equals model, we can start getting rid of them and just specify the type. Now, this is not a strict type. This is more of a guideline for us, the developers, and the interpreter what to expect. And yes, the first impression might be like these are class attributes, not instance attributes. But this is what the data class decorator is there for. And what's going to happen under the hood is that this class will be generally rewritten with the init function. And once we will initialize the object, these attributes will be initialized on the object instance as normal. For example, here we define car1, which is an instance of a class car, defined with the following values. So make is BMW, Mini Cooper is the model, surprise, surprise, and price is 27,085 units of money. Then we print it. And surprisingly, instead of the address in the memory where this object is stored, we will get an actual representation of these objects with the values of its attributes. And as you can see, we have a nice representation of the car1 object, because in data class, the wrapper magic method is implemented by default. If you got no idea what am I talking about, go check out the video on magic methods. All right. Another method that is implemented by default is called EQ, so equals. In general, it allows us to compare or check whether two objects are equal to each other, as in they have the same values of their attributes, and the number and the name of the attributes are the same as well. So now we can compare car1 and car2, two distinct objects, with the double equal sign, and we can check whether they equal or not, and of course it returns false. But without the EQ magic method, it returns false regardless, because it only compares the addresses in memory, and of course they will be different. And now if I will create a copy of car1, car3, and I'll compare them two, then I will get true, because indeed the number of attributes, their order, and their values are the same. However, despite all these cool bells and whistles, this is a regular class. So we can define a method within this class. Let's say it's going to be a promo of some sort. So let's say when it is called, it will return a formatted string where it will represent the make, the model, and the price. So let's say return then f and self.make. Actually, let's make it a proper promotion. So I'm going to say something like self.model. So this model by this manufacturer, and it's going to be for just, and then the price. So let's give us some space for the manipulation of this method later on. So just a regular method promo, and now we can call this method via the dot operator on our object. So I'm going to comment that out, and I'm going to say something like print. It doesn't matter which car, so car1 dot promo. And of course, because this is a method, don't forget to put the brackets. And that, of course, returns what we would expect, Mini Cooper by BMW for just 27, whatever the price. But you might be asking yourself, all right, then, if the init function is pretty much hidden under the hood of data class mechanics, then how can we implement a certain behavior when we, say, initiate an object? And for this reason, we have a special method which is called the post init. And so this function will be called when the built-in init method will finish. So let's transform our car class. We're going to define this post init function, and we're going to cut and paste parts of the promo method to that function. So let's do that. I'll make sure promo is not it's not a method anymore. So let's say every time upon the initialization of the object of a class car, we're going to be getting this string. So now the promo is not a method anymore. We need to get rid of the brackets. And now you can see the same result, but with the post init function. Another cool thing about data classes is that we can define some default values for the attributes. So for example, I can define a default make, default model, and default price. And even if I will create an instance of a class car without defining any of these values, I will still get an object with these default values. So for example, make will be, let's just transfer all those values to the default. So BMW, Mini Cooper, and the price is 27 something. And of course, later on, we can extend this mechanics a little bit because hard coding these values might not be as cool as, say, having a randomizer defining the price. But we'll do it right after I'll show you the mechanics, how it works in general. So let's say I will comment everything out and I will define a new object. Let's say it's going to be car 0, just for the sake of the example, and it equals car. So here we don't specify any values. Nevertheless, if I'll print car 0, I will get BMW, Mini Cooper, and the price. How cool is that? But I think what can be even cooler is if we will define this price via some kind of a dynamic behavior, let's say a randomizer. And data classes module allows us to do that as well. All we need to do is we need to import something called field. So this function will allow us to sort of extend the mechanics of this, if you'd like, fields in the class. So we can replace the price with the field function, and it has some arguments here as well. We'll specify the default factory and we'll make it equal to the method, which we will define as well in a second. So price gen. So in essence, how it works is that the default factory will be called when a default value is needed for this field, and the value will be supplied by the function called price gen. This is essentially a randomizer where we'll generate a price within a certain range. So we'll specify the range via the rand range, and we'll make it from, let's say, 20,000 to 30,000 units of money. And basically what's going to happen now is that every time we instantiate car0 object and print it, so every time we call the function print, we're going to get a different value for the default price, which is kind of cool. Well, not really cool, but at least it's not as straightforward as a hard-coded version. All right. Another important point I want to make is that now nothing prevents us from changing those default values. In other words, we can redefine them in each new object we create, and Python will not stop us from doing so. So I'm going to illustrate that with a car4 object, which is an object of a class car. And once again, I'm going to define, or let's say redefine, the default values for, let's say, car4.make. And if I defined make as currently is BMW, but if I'll define it as, say, Renault, I can easily do that, and I will not get into any type of error for doing that. So down below, I'm defining car4.make, and I write something like Renault or Renault. And I'm going to copy that print statement and paste it down below so we can see the difference. And as you can see, BMW was swapped to Renault. But what if we want to change the standard behavior and prevent it from happening? Well, all we need to do is to switch the argument of the data class decorator from false to true. And this argument is called frozen. So if we'll set up to true, because it is set to false by default, so if we'll run the code now, we'll get into an error. And in particular, it is frozen instance error. It says we cannot assign to field promo. So in this case, it caught up on the assignment to the promo, but it is generally will not allow us to do any business with any instance arguments as well. And just to give you another example, so let's say we'll define a new method, and it is a class method, so it will, same as post init, it will try to change the value or reassign the value for one of the arguments from within the class. So let's say it's going to take promo value, and it's going to set up price equal to this promo value. So I'm going to specify self.price equals promo value. Okay, so let's make it consistent. So let's say promo price. So self.price equals promo price. And let's try to launch the code now, and we should get another error, which is basically the same error. We cannot reassign any of the values. So let's comment that out to make sure I've commented something I shouldn't comment out. Comment out. All right. That should work. Just to make sure we definitely understand what kind of method has caused the error. So we're going to call new promo, and we're going to pass the value of 20,050, let's say. All right, and as expected, we get this same error. This was an introduction to data classes. I would recommend you to check them out in the official documentation. That was V. Please give this video Emperor's thumbs up, toll the bell, and subscribe. And I'll see you in the next lesson. Bye for now.